Hello everyone and welcome back to this Python programming course where you are going to learn everything you need to get started programming in Python. In today's video, we are going to look at inheritance in object-oriented programming. So let's jump right into it. Inheritance enables us to define a class that takes all the functionality from a parent class and allows us to add more. Inheritance is a powerful feature in object-oriented programming. It refers to defining a new class with little or no modification to an existing class. The new class is called a derived or a child class, and the one from which it inherits is called the base or parent class. The Python syntax for inheritance in object-oriented programming goes as follows. We have class, base class, body of base class, class, derived class with base class as a parameter, then body of derived class. The derived class inherits features from the base class where new features can be added to it. This results in a reusability of code. The benefits of inheritance are: it represents real-world relationships well, it provides reusability of code, we don't have to write the same code again and again. Also, it allows us to add more features to a class without modifying it. It is transitive in nature, which means that if class B inherits from another class A, then all the subclasses of B will automatically inherit from class A. So now we are going to look at a simple example of inheritance in Python. So here we have a simple program to demonstrate inheritance. We have class person, which inherits from object class, have our constructor def init self name, where self.name takes name. We have instance method to get the name, def get name self, and we have to return self name. That is when we call the get name method, it will return the name of that instance. Then we have to check if this person is an employee. At the level of person class, we return false because not every person is an employee. Then we move to the inherited or subclass, which is employee, and we have to note that we have to put person in bracket. So we have class employee in bracket person because employee inherits from class person. Then we have here we return true because every person from the class employee is an employee. So we have def is employee self and we return true. Then we go to our driver code, which is our main code, and we create different instances of the classes. So we have employee1, that is emp1 equals to person Peter, print employee1 dot get name employee1 dot is employer. So here we will have printed to the screen the name and whether or not employee1 is an employee or not. Then we have employee2 employee call print. Then we will have employee2 dot get name and employee2 is employee. So note the difference between the creation of the two instances. Employee1 is created from the class person and employee2 is created from the class employee. So if we save this and run, we will have. So as output here we have Peter false and then Paul true, meaning employee1 Peter is not an employee while Paul is true, meaning he is an employee. So from the above example, we created the object employee1, that is Peter, from the person class, and that's why it shows that this instance of the class is not an employee because we used the person class and the instant method we used there was return false, that is employee has to be returned false because not every person is an employee, making the value of employee1.employee to be false. From the second object, employee2, that is Paul, we created it from the class employee that inherited from our first class person. But in the class employee, we use an instance method to return true for every person created from the class employee. That is why we have true when we get employee2 dot is employee. Next, we are going to look at subclassing, which is the process of calling constructors of a parent class. A child class needs to identify which class is its parent's class. This can be done by mentioning the parent class name in the definition of the child class. So now we will look at an example of a code to demonstrate how parent constructors are called. Okay, so here we have a Python code to demonstrate how parent constructors are called. We have our parent class person. Init is known as the constructor. So we have def init self, name and ID number. Self.name takes name and self.id number takes ID number. Then we have a method def display self, which belongs to the parent class person. So we have print self.name, then print self.id number. Then we proceed to creating our child class employee person, meaning that the employee inherits from class person. We have def init self, name, ID number, salary and post. But here we will just assign values to self.salary, which takes salary, and then self.post, which takes post. So we are not assigning any value to name and ID number because we will actually inherit those from our parent class. So we now invoke the init of the parent class to be able to get the name and the ID number. So to do that, we type person.init self, name and ID number. So this is how we are able to call a parent's constructor while being in the child class. So after that, we move on to the creation of an object variable or an instance. A equals to employee. So A belongs to the class employee, and we give it a name Peter, the ID number, the salary and the post. So then we move on to calling a function of the class person using its instance. So while using the instance A, which is of class employee, we will be able to access a method defined in the parent class person. So we write a.display, and with this done, we will be able to get to the screen displayed the name and the ID number of that instance. So if we save this and run, we have Peter and 886012 printed to the screen, with Peter representing the name and then the number representing the ID number. So the program does exactly what we wanted it to do. It's the variable defined within init are called instant variables or objects. Hence, name and ID number are the objects of the class person. Similarly, salary and post are the objects of the class employee. Since the class employee inherits from class person, then name and ID number are also objects of the class employee. So if we forget to invoke the init of the parent class, then its instant variable will not be available to the child class. When a child class inherits from multiple parent classes, it is called multiple inheritance. The derived class inherits all the features of the base cases. The syntax of a multiple inheritance goes as follows. So here we have class base 1, body of the class base 2, body of the class, then class derived having base 1 and base 2 in bracket, then we have the body of the class. Now let's have a Python example to show how multiple inheritance works. So here we have class base 1, we have our constructor def init self and name. So we have self.name gets name. Then to get the name, we defined a getter method get name self, and we return the self.name. Then we have class base 2, which is the second parent class, constructor def init self age, self.age gets age. Then to get the age, we have a method def get age, and we return self.age. So now we are going to create a class inherited from both base 1 and base 2. So we have class child base 1 and base 2 in bracket. Then we write the constructor def init self name age and address. Then we call the constructors of the base 1 and base 2 classes, base 1.init self and name, base 2.init self and age. Then we have self.address taking address. So we have another get method to get the address. So def get address self, and we return self.address. Remember, if we do not invoke the constructors of the parent classes, then the objects of the parent class will not be available to the child class. So with that, we write the driver code. We have g equals to child, we have the name dev1, 23 representing the age, and then Noida representing the address. So if we print g.getName, then g.getAge and g.getAddress. So if we save this and run, we will have def1 23 then Noida printed to the screen, therefore doing exactly what we wanted the code to do. So this is how we work with multiple inheritance in object-oriented programming. We can also inherit from a derived class. This is called multi-level inheritance, and it can be of any depth in Python. In multi-level inheritance, features of the base class and the derived class are inherited into the new derived class. The syntax of the multi-level inheritance in Python is as follows. So here we have class base, we have body of the class, we have class derived 1, which inherits from the base class. Then we have the body of the class, and finally we have class derived 2, which inherits from the derived class 1, which itself inherits from the base class. Then we have the body of the class. Now we are going to look at a Python program to demonstrate multi-level inheritance. For that, we'll simply modify the code we created for multiple inheritance. Okay, with this done, here we have our class base, which inherits from the main class object. Then we have our constructor def init self-name self.name equals to name. So to get the name, we define the get method, get name self, return self.name. So we then move to the inherited class or the subclass of the class base. So we have class child, which inherits from the class base. So we have our constructor def init self age, then base.init self name, we then have self.age. So here we invoke the constructor of the class base, then we have self.age, which gets age. Then we have our get method to get the age, and we return self.age. Then we move to the inherited class, which inherits from the class child. So we have class grandchild inheriting from the class child. So we have our constructor get init self name age and address, calling the constructors of child. We have child.init self and age, then self.address gets address. So finally we have our get method get address, and we return the address. So, and in our driver code here we have g equals to grandchild, and then def1 23 Noida print g.getName get age and get address. So if we save this and run, we have an error saying name is not defined, and that is because at a couple of areas when we were just modifying the child class, we did not include the name as the other parameter. So let's correct that and test our code once more. So here in our child class we will have self, then name, and in our grandchild class we will have self name once more. With this we can save our program and run, and with that done we have def1 23 and Noida printed to the screen, meaning our program functions perfectly well right now. So here we have been able to implement the concept of multi-level inheritance, in which a class child inherited from the class base, then in turn a child grandchild inherited from the inherited class child. So this is basically it for this video, but before we end this video, I am going to paste a practical exercise here for you to keep learning and implementing the concept of Python inheritance in object-oriented programming you've learned today. The link to the solution to the practical exercise is attached in the video description below. But before checking it out, make sure you try writing the code first. In our next video, we are going to look at encapsulation in object-oriented programming. So, see you soon.